Okay, so let's jump right into it. We're living in a time where AI is doing some truly incredible things, aren't we?
Okay.
It's crunching these just unimaginable amounts of data, predicting complex systems, with uncanny accuracy.
Yeah, and even generating art and music that really makes you pause.
Exactly. It really begs the question, where does that unique spark of human insight, creativity, where does that end? And the sheer power of machine capability begin?
That's the core question, isn't it?
So today, we're taking a deep dive. We've got this fascinating stack of sources you've shared with us.
Right.
And these pieces, they explore AI's rapidly evolving role in creativity, how it's impacting the scientific method itself, and maybe most profoundly, what it tells us about the very nature of scientific discovery.
So our mission here really is to try and cut through the noise, pull out the most important insights from all this material for you.
Okay.
We'll unpack the exciting ways AI is enabling breakthroughs, think climate science drug discovery. But importantly, we'll also look critically at its current limits, especially when you get into these deeply human elements like creativity, like that unique moment of scientific discovery.
Right, the nuances.
Exactly. We're here to help you navigate those nuances in these pieces and see what's really going on.
Great. So we'll be your guides through this. And I guess we're better to start than by looking at how AI is already fundamentally changing the game in science.
Makes sense.
One source makes a really compelling case for AI's growing impact on the scientific method itself.
Yeah, and what's fascinating here is that AI isn't just a tool scientists use after the hard work's done. According to this source, it's getting involved at pretty much, every stage of the scientific process now. It can actually help with generating hypotheses.
Wait, hang on. So AI isn't just testing our ideas, it's helping come up with the ideas in the first place.
Exactly. By sifting through these absolutely massive data sets.
Yeah.
I mean, far more than any human ever, AI can spot patterns, correlations.
Things we might miss.
Things we definitely miss. And it can even suggest potential hypotheses that, a human researcher might not have considered because they're looking at it from a different angle, maybe.
Okay, like in genetics, you're saying, where AI algorithms just chew through mountains of DNA data to spot unexpected gene behaviors, or climate science, where it looks at historical data patterns to suggest new angles on future climate impacts.
Yeah.
It's almost like AI is this research assistant tapping you on the shoulder saying, "Hey, boss, have you thought about this possibility?"
That's a really good way to put it. And the source is careful here. It emphasizes this is about enhancing human creativity and intuition at this stage, right?
Yeah.
Not replacing it.
Enhancing. Okay.
Then, as you move towards, say, experimentation, the design phase, AI can help design more efficient experiments.
How so?
Well, it can suggest optimal setups to save time, resources, or even propose alternative approaches that just might not be in a human's standard toolkit.
I love the examples the sources use here, like pharmaceuticals speeding up drug discovery by predicting how vast numbers of compounds will interact.
Yeah, that's huge.
Or in physics, simulating complex experiments that would be way too expensive or maybe even dangerous to run in the real world.
Right. And as one piece points out, AI doesn't get tired. It works 24/7. And its computational speed is just, it's mind-boggling.
Yeah, hard to even wrap your head around.
And then, of course, comes AI's, classic strength, data analysis and interpretation.
Right, number crunching.
Exactly. Modern science is just drowning in data. Think about astronomy, biology, particle physics. The sheer volume is impossible for humans to process manually anymore. So AI acts like a master puzzle solver here, taking all these disparate, complex pieces of data and somehow fitting them together to reveal hidden insights.
Those examples are so vivid. Astronomy using AI to make sense of telescope data, understanding cosmic phenomena, or biology analyzing DNA sequences to find disease connections we never saw before. AI is really uncovering the stories hidden within the data, as one source puts it. It's quite poetic, actually.
It is, and connecting this to a huge real-world challenge, another source dives deep into how AI is fundamentally changing climate modeling, specifically for sustainable urban planning.
Okay, this is where the potential gets really tangible, right?
Yeah.
For everyday life.
Absolutely. AI, especially advanced machine learning, deep learning techniques, it's dramatically improving the accuracy of climate predictions.
Okay.
It's boosting the efficiency of the computational models, which are incredibly complex, And importantly, it's integrating these incredibly diverse data streams.
Like what kind of streams?
Everything from satellite imagery, ground sensors,
Hmm.
potentially even things like social media posts or IoT networks in cities, all sorts of inputs.
Wow.
And the source outlines this clear process. They even have a diagram for it. It starts with getting the right data, developing the model, so collecting, processing, validating all that climate data.
Right, the groundwork.
Then comes the analysis and prediction part, where the AI models analyze trends, improve the resolution of forecasts, make predictions.
Okay.
And finally, and this is crucial, is the policy action and implementation step. Translating those complex insights into practical strategies for urban planners.
For things like disaster mitigation,
Yeah.
resource management.
Exactly. Infrastructure planning. That figure they include, showing the steps from data collection right through to policy action, it's really insightful.
And the case studies they mention, they show the breadth of this, don't they? Improving wind energy forecasting,
Mm-hmm.
taking broad atmospheric data and downscaling it to get specific local predictions. Predicting temperature, air quality,
Drought prediction.
even monitoring deforestation in places like the Amazon.
Right, and they mentioned different AI techniques being used, like hybrid models, transfer learning. It's not just one approach.
No, it depends on the specific challenge. And while, the success can vary depending on local factors,
Yeah.
tech infrastructure, data availability.
The sources really agree that AI is demonstrating transformative potential for building more sustainable and climate-resilient cities.
So it's clear, AI is already this revolutionary tool. It's reshaping almost every phase of scientific inquiry, offering powerful solutions to massive problems like climate change.
No question. It's changing the landscape.
But for all its power with data and prediction, AI doesn't replicate everything humans do, right?
Right. That's the other side of the coin.
The sources you sent also explore areas where the human element still seems, unique, particularly around creativity and intuition. One piece specifically tackles AI and creativity.
Yeah, this article from a Brainy Bar event, it really zeroes in on a key limitation. It argues AI, as it currently exists, will struggle to replace human creativity because it lacks emotion.
Emotion.
Dr. Dean Burnett is quoted saying, "Human art is the process and outcome of a brain that is using emotion to guide its thoughts, output, and decisions."
Okay.
AI does not have that. It is all pure logic.
That makes intuitive sense, doesn't it? Emotions are so fundamental to how we process information, how we operate, how we remember things even.
Burnett points out it's much harder to retain information if it doesn't have any emotional resonance for us.
Like in advertising, right?
Right.
You often use an emotional context to make a product stick, even if the product itself isn't inherently emotional.
Exactly. And he notes, emotions are often faster than our conscious thought processes.
Mhm.
We make decisions more emotionally than we probably realize.
Yeah.
Emotions are described in this source as the bedrock of cognition, infusing all our thinking.
Wow. Bedrock of cognition.
Yes, it feels
Yeah.
deeply rooted in our human nature. Another speaker at that same event, Graham Noble, he pushes this further. He argues that true creativity is an innate human quality.
Innate. How so?
He says it needs to be totally unpredictable. It has to surprise us. He calls it people-powered, not machine-powered,
Okay.
suggesting it's about breaking the rules, which AI isn't really designed to do that in the same way.
Although Dan Bowers offers a slightly different angle from that same event.
Right, there's a counterpoint.
He suggests science can actually inform creativity by giving us better analysis of human emotions and preferences.
Okay, so data about emotion.
Yeah. He argues, by better understanding the science of emotion, we can inspire better creativity. Because ultimately, consumers don't think, they feel first.
Interesting.
So while the spark might be human, maybe data about human emotion can guide the creative process. There's a bit of a tension there between those views, isn't there?
Definitely a tension. And what's fascinating is how this whole conversation about creativity and emotion, how it connects to another concept explored in your sources, the role of intuition in science.
Intuition. The gut feeling.
Kind of. While science is obviously built on logic, rigorous proof, this piece argues that intuition plays this critical, sometimes even irrational role in scientific research.
Like the famous Archimedes bathtub eureka moment. Or is that just the story?
Well, maybe less mythically. Think about modern labs. Bruno Lemaitre, he's an immunology professor, quoted, he compares research to a police investigation.
Okay.
When old hypotheses fail, scientists use imagination to come up with new ones, right? And then intuition helps them sort through which ones are most promising to actually test.
So it's a filter.
In a way, as he puts it, we use intuition to discover and logic to prove.
I like that. Discover versus prove.
And intuition isn't just one big flash either. It guides countless smaller decisions researchers make every single day.
Like what?
Choosing which experimental model is best, making necessary trade-offs in design when time and resources are tight.
Mm-hmm.
Frédéric Blanc, a particle physicist, describes needing a feel for the right analysis method when you're faced with terabytes of data from CERN.
A feel. Wow.
Or in chemistry, synthesizing complex materials. Intuition helps scientists narrow down literally millions of possible experiments to a manageable few to actually try in the lab.
So it's built up over time, through experience.
Yeah. Exactly. It's built through experience, deep knowledge, and even through collaboration, that collective intuition that emerges from constant discussions in a lab. The water cooler effect they mentioned.
Yeah, right. Bouncing ideas around.
Yeah, and it can even be cultivated, taught, encouraging students to visualize concepts, reflect critically on why their initial hunches might be wrong.
Okay. So this brings us to a really profound question, tying these ideas together. If creativity relies on emotion, unpredictability, and a scientific discovery is often guided by this intuition, which is described as non-logical, deeply human. How does AI, which is all about logic and pattern recognition, fit into the actual act of making a discovery, beyond just being a powerful tool?
That is the question, isn't it?
And that leads us straight to the core question of one of the most interesting sources you shared.
Yeah.
Can AI actually make scientific discoveries? Not just help us make them, but be the discoverer itself.
Yeah, this philosophical paper really tackles that head on. And it argues that, as of now, AI doesn't meet the criteria for what we traditionally consider an independent scientific discovery.
Okay, why not?
They frame discovery not just as finding something new, but as something that requires, well, a specific kind of capability and self-awareness on the part of the agent making the finding. An epistemic achievement, they call it.
Okay, epistemic achievement. Let's simplify that a bit. What kind of capability are they talking about?
Okay, think of it this way. When you stumble upon something important, they use the example of a boy finding an ancient ruin, like the Domus Aurea,
Okay.
versus Columbus discovering America. The boy found something amazing, right? But Columbus's finding, however complex and problematic the history is, it was linked to his competence, his expertise in navigation and geography at the time. The source argues a real scientific discovery needs to be linked to the agent's competence in that field.
So it's not just finding something, it's finding it in a way that shows you actually understand something about the domain you're working in.
Precisely. And they suggest two ways this competence is shown in science. Either the finding comes from the kind of reasoning scientists in that field actually use.
Like Fleming using biological reasoning to figure out what his mold was doing.
Exactly. That's one way. Or the agent can explain the scientific significance of the finding based on existing knowledge.
Okay.
Like an expert recognizing a new species and knowing why it's important, biologically, even if they found it by chance.
And the sources suggest current AI, especially deep learning, it might struggle here.
Yes, that's the argument. Because while AI is amazing at finding correlations, making predictions from data, its process is often a black box.
Right. We don't always know how it got the answer.
Exactly. We might not know why it made a certain prediction or identified a specific pattern.
So it might find something really interesting, but can it truly explain why it's scientifically relevant? Linking it back to established principles or theories in a way that a human expert could.
That's a major hurdle, they point out. AI can give you an output, a prediction, but it struggles to provide the logical steps or the causal connections that make sense within the existing body of scientific knowledge.
Right.
Even really powerful systems like AlphaFold, which predicts protein structures with incredible accuracy.
Yeah, amazing tool.
Amazing. But it still needs human scientists to integrate those predictions, design follow-up experiments, build the theoretical framework around them. The human is still essential for what one source calls the context of justification, making sense of it all.
Okay, so competence is about understanding the why and linking it back to existing knowledge.
Sure.
What's the second key idea about discovery they bring up? Self-something.
Self-reflection or self-awareness, basically being able to reflect on your own knowledge and, crucially, your own uncertainty. Can the agent assess how confident it should be in its own findings? Can it recognize when it doesn't know something or when its knowledge is limited?
Like the archer analogy they use in the paper.
Yeah, tell me about that one.
Well, it's not just about hitting the target that's good performance. It's about understanding why you'll hit the target based on the wind, the distance, and knowing your own skill level.
Right.
Being aware of your capabilities and your limitations.
Exactly. It's about having a sense of the reliability and the limits of your own process, your own knowledge, and AI currently struggles significantly with this.
How so?
Well, while AI models might output, say, a probability score, that score doesn't always accurately reflect true confidence or uncertainty, especially when the AI encounters data that's different from what it was trained on. Remember the white cat, black cat example?
Vaguely. Remind me.
An AI trained only on white cats might confidently identify a black cat as not a cat, or maybe even misidentify it with high confidence, because it doesn't really understand catness, just the patterns in its limited training data.
Got it. So the AI might be highly confident in a prediction that's completely wrong because it doesn't grasp the underlying concept, just the surface patterns?
Precisely. The sources argue that unless AI develops truly robust ways to estimate its own uncertainty, to know when it's on shaky ground or has gaps in its knowledge, any findings it makes might just be blind findings.
Blind findings.
Yeah, they require human experts to come in, recognize the significance, validate them using human competence and reflection.
Okay.
And this aligns perfectly with another source's point that AI won't simply replace researchers because it lacks that critical human capacity for interpretation, for drawing nuanced conclusions.
Right. So pulling all this together then, AI is this phenomenally powerful tool, no doubt. It's accelerating science by crunching data, finding patterns, optimizing processes.
Transformative.
But according to these sources, it doesn't yet possess the kind of confidence needed to truly understand why its findings are scientifically relevant in a human-like way.
Right, the deep understanding.
And it lacks that crucial self-awareness to reflect on its own knowledge and uncertainty.
Which means that spark of creativity we talked about, the intuition that guides inquiry, and the deep understanding and self-reflection required to make sense of a finding place it within the broader tapestry of knowledge.
Yeah.
Those elements still very much belong to the human scientist. For now, at least.
These sources really drive home that AI is best viewed as an incredible complement, right? A partner that extends our reach, our capabilities.
Yeah, enhances us.
Rather than a replacement for human intellect and creativity.
Yeah.
It's opening new frontiers with us, not instead of us.
Well put. So, as you, the listener, encounter AI in your own work or interest, maybe it's suggesting a design, predicting a trend, analyzing data, remember the distinction these pieces highlight. AI is unparalleled at finding patterns, optimizing processes, making predictions based on the data it's trained on. That's its strength. But understanding why it works, critically questioning its outputs, connecting insights to broader knowledge, making those intuitive leaps that guide the next steps.
Yeah.
Those often still rely on unique human insight, experience, and reflection.
Which leads us with a really interesting thought to carry forward, doesn't it? Building on this idea of what discovery truly entails.
Go on.
If a machine, an AI, sifts through data and flags something entirely novel and significant, something no human has ever seen before,
Okay.
but it can't explain why it's relevant in a way that maps to our scientific understanding and has no internal sense of confidence or doubt about its finding, can we truly call that a scientific discovery in the way we've always understood it? Or is it something else entirely? A new kind of finding, maybe. Something that pushes us to redefine the word discovery itself for the age of AI.
That's a deep one. Definitely something worth mulling over.